In the second last session that we will cover today, it's my pleasure to introduce as a moderator Dominique Silva. Dominique was a person that challenged me quite a bit at a breakfast debate in the European Parliament, and I quickly understood that she's very knowledgeable about heat pumps from a technical perspective, and we had great discussions about fast deployment. She's today working as innovation leader in train technologies, and she's also a big fan of Walt Disney movies and documentaries. And she will talk with us and talk to us together with Andrea Vallejo from Johnson Controls, Sander Gehlen from Gehlen Counterflow, Michael Bantel from Syntef, and Stefano Bello from Clivet in Italy. I hand over to you, Dominique, please.
Thank you, Thomas, and thank you for revealing my secret about being a big Disney fan. I also have a big confession to make. So I was a product manager for heat pumps for over 5 years, and as Thomas alluded, completely passionate about the technology, but then something called COVID-19 happened, and I was moved to a new role within the company, focusing on indoor air quality and healthy building movements. So I confess that I felt like a bit of a traitor to the industry, but it only took me one conversation to realize that the conversation about indoor air quality and healthy buildings is actually not different and very connected to the conversation we're having here today about green buildings. Now, let me give you a practical example from this morning. I heard that a few of you were complaining that you were cold, myself included. Some people even complaining, my head felt warm, but the rest of my body was cold. And Thomas was very kind enough to explain that the reason why you were feeling that was because of increased ventilation. And this has just been the recipe all over the world that we've given in order to improve the indoor air quality in buildings. Just increase ventilation, bring in more fresh air, dilute the air. You felt the consequences of that, which is the effect of thermal loss. Now, Thomas, again, very kindly decided to tell us to compensate that thermal loss by running to the food court. In most cases, with most of our customers, what's going to happen is they're going to turn up their thermostats and turn up their heating systems, right? So we're now entering this very interesting paradox for our industry as a whole, which is on one hand, the COVID-19 pandemic has accelerated our conversation around healthy buildings and creating healthy spaces for people. And there's this interesting discussion, but also a bit of a conflict coming, which is how can we make these spaces healthier but efficient at the same time? Now, because of my past and because of my passion for heat pumps, the connection that I made was one of the great advantages of heat pumps, and José Loggia spoke to that earlier, is we are eliminating direct emissions from heating systems. Now, if you think about the main recommendation to improve indoor air quality, which is increase your outdoor air ventilation, what are we doing? We're bringing outdoor air inside. So the cleaner that air, in part due to the deployment of heat pumps, the cleaner the indoor air as well. Did you see that? Does that make sense? Okay, so I'm not the only crazy one here. Fantastic. So we are not here to talk about healthy buildings, but I felt the need to explain why my betrayal is not really a betrayal. I am so excited to have here a really, really interesting and very much more intelligent than me panel of speakers. And today, for this session, we're going to turn the conversation around a little bit. So far, we've been talking about consumers in the residential sector, and how do we get consumers to adopt heat pump technology. We've talked a lot about the building environment, a little bit about cities, a little bit buildings, renovation. How do we get building owners to convert? Now let's talk about a completely different market, which is the industrial sector, industrial processes. Let me start here with the question, just to make sure everybody had a cup of coffee and is awake. Who here in the audience, please raise your hand, is representing a heat pump manufacturer? Fantastic. I think that's close to 90% based on I'm losing my sight a little bit, but that was a lot of hands. You agree? A lot of hands, okay. And who here is representing an industry association? So an association of heat pumps. All right, so that's the other 10%. Great. So this is fantastic. It confirms my theory that we probably don't have people here who can talk to us about the needs and the challenges of the industrial sector and industrial processes in particular. Now, an interesting thing about my job as product manager, believe it or not, the part that I enjoyed most was not talking to engineers. As fascinating as they are, they can give you headaches. The favorite part of my job was talking to customers. And as part of my market studies, I got the opportunity to talk with industrial customers. Now, I was coming from a commercial background. I was used to talking to HVAC engineers, designers, installers, contractors, so I pretty much understood the commercial environment. When I switched to the industrial, I understood that the problem that they are trying to solve when they come to manufacturers like us is completely different. They are not thinking about hot water or cold water. The job that they need to get done is about something that they need to produce. That's their outcome. That's how they get measured, right? So when we come in and we talk about, no, electrification of heating is the best thing ever, you need to switch to technology, we need to be in mind that industrial process owners have to think about all the different components in their process beyond heating itself. So that's one challenge, which makes it a little bit harder to switch to a different technology because of the added complexity. The second thing is, if a heating or cooling system fails in a home or in a commercial building, worst case scenario, you're going to have people calling you and complaining, like we did this morning, it's too cold or it's too warm. If a heating or cooling system fails in an industrial process, production stops, and we start losing money. So that's also a different element in the conversation with dealing with industrial customers as well. So I'm giving you all of this perspective because the whole day we've been talking about consumers and building owners, and I want to make sure you keep this in mind when we now enter into the discussion about how heat pumps can help accelerate the decarbonization of the industrial sector, and keep this in mind when you think of your questions, which we will have time for. Why the industrial sector? I am an engineer at heart, so obviously I brought numbers. So let's just talk here a little bit about the impact of the industrial sector itself. The industrial sector in Europe is responsible for 25% of the final energy consumption in Europe. So a quarter of the energy that we produce, the industrial sector consumes it all. Surprisingly, and I didn't know this until I did my research, so thank you for that, 66% of this final energy consumption is for heating purposes. So we're here to talk about the decarbonization or electrification of heating. This is a great place to start. The other thing that triggers my mind is if you think about industrial processes, not only are they consumers of heat, but they have processes which actually generate heat, right? José Laloggia, sorry I keep referring to José Laloggia, it's a coincidence that we're from the same company, so I hear him a lot and it's in my brain. But he mentioned a lot this concept of just wasting energy. And again, I'm going to give Thomas Novak some credit here because he actually coined the expression of thermal pollution. Any heat that we reject that ultimately ends up in the atmosphere, we don't pay attention to it because it's not particulate matter, it's not emissions, we can't see it, so we ignore it. But it's pollution, right? Because instead of reusing it, recovering it, and repurposing it, we're actually just consuming more energy to generate it somewhere else. So there you go, Thomas. I remembered. Almost 3 years. See? I don't remember a lot of other things, but I do remember that. All right, so you've heard a lot from me. Was that okay? Yep. All right, so I'm going to introduce our speakers. I'm going to start here with Andrea Vallejo. Oh, before I introduce Vallejo, I want to give a big congratulations to the EHPA. This is the third event that I attend, and every time I come, I see more women. So I think I'm connecting the dots again, and I'm remembering about Dan Caesar's keynote speech at the beginning, and he said one of the keys to success, if you want to accelerate adoption, is to be more persuasive. That's a quality we women are quite known for, it's to be persuasive. And I actually think, taking this back to the consumers, women and wives actually drive the decisions at home. So get an electric vehicle for your woman, not for the husband, right? That's number one. But a big congratulations in bringing more women into the heat pump industry as well, I'm always super happy. So now Andrea, just because I just realized that we have something in common. So Andrea Vallejo is the Vice President and General Manager of Johnson Controls Global Industrial Refrigeration since 2019. I asked her if this feels like a very long time, and she says that 2 years went by like this, right? So she's also a member of the Johnson Controls Sustainability Leadership Committee, and prior to this, she held several operational and general management responsibilities in Europe, Africa, and Latin America. On top of all this, Andrea is also currently the Vice Chair of EPE, solidifying her position as a global sustainability advocate. Next year, and before I pass on to Michael, who's attending us virtually, I'm going to go here to Sander. Sander, who joined me in asking a complicated question from the audience in the previous session. So Sander is the Managing Director of Gielen Counterflow. Did I pronounce that right? I'm getting better at this, Sander. He's leading a team located throughout the Netherlands, USA, Argentina, China, and Vietnam, and focuses on developing, marketing, manufacturing, installing, and servicing counterflow dryers and coolers for the food and feed industries worldwide. To give you an example of something that Sander's company has achieved, they introduced the first electric dryer for the feed and food industry, which recovers up to 65% of all drying energy and water from the dry exhaust, and is using high temperature heat pumps for heating the drying air. Thank you, Sander, for using high temperature heat pumps. We salute you. Stefano Bello, he is the CEO of Clivet, a large HVAC equipment manufacturer. Stefano has enjoyed a long career. I think you told me 27 years that you've been in this industry. A little bit longer than me there. I've got some catching up to do. So he's enjoyed a long career in international business development with projects in Spain, UK, Netherlands, France, Germany, Russia, India, and the UAE. I'll ask you later which one was your favorite. He's managed the company since 2008, first as a general manager, then as a CEO, and he was also leading the integration of the Midea Group in 2016. On top of all of this, Stefano has a little bit of free time, which he uses to serve as Vice President of Assoclima, which is the Italian Association of Air Conditioning Systems Manufacturers. And he further acts on his commitment to promote the principles of sustainability within the HVAC market. Michael, it's so nice to have you emotionally with us. Can you hear us okay?
I hear you very fine, thank you.
Awesome, and you look great as well. So I'm also happy to introduce Michael. Michael Bantel is a senior research scientist at Syntef Energy Research, and he is focusing on the development of high temperature heat pumps and their integration into the process industry. The main motivation behind his engagement is to decarbonize thermal processes whenever possible, but also to reduce primary energy demand. So really happy to have you here with us, Michael, Andrea, Sander, and Stefano. So you're tired of hearing from me, I understand. So let's get to the interesting part. And I, Michael, if you will allow me, would love to start with you, because I was doing a little bit of research and discovered that you were one of the co-authors of a white paper which is focusing on what it takes to decarbonize the industrial sector in Europe. So to get us started in this conversation, can you briefly talk us through which industrial sectors, in your view, have the highest potential to use heat pumps, and then what this would mean for the decarbonization of the European industry as a whole?
Yes, thanks. Yeah, when we looked at these numbers about how much we could actually save in emissions for the European sector, we were very much also had to look at the temperature levels at which different sectors are actually using energy. And maybe to no surprise, food, feed, and beverage sector has a very much temperature demand in the range of 100, 150 degrees. And with already, I think, today's technology, we are able to supply heat at this temperature level. So the food and beverage sector, feed sector as well, is maybe one of the first sectors that can be electrified by heat pumps, especially when we talk about high temperature heat pumps. I think the potential there is around a little bit above 100 terawatt hours per year. Second sector is, of course, pulp and paper. Also here, the energy demand is normally in the temperature range 150 degrees, typically 5 to 10 bar steam supply. So this is temperatures with temperature ranges which can be supplied by the heat pumps. Both sectors have in common that they also at the same time are submitting the excess heat at the same time, which is needed to run these high temperature heat pumps here. And of course, there are also some potential in other sectors, chemicals as well. And if we summarize these numbers, we ended up and concluded that I think up to 500 terawatt hours per year can be electrified by heat pumps already today. If we have heat pump technologies or high temperature heat pump technologies available, which deliver somewhere in the range of 100 to 200 degrees process heat, basically. And this sums then also up that up to, with current electricity mix, I think up to 150 megawatt the megatons CO2 emissions per year can be saved by this technology. And this is already technology which is available today and don't need to be invented first. Thanks.
So I'm hearing a common thread, which is technology is available and there's a very big part that we can already address within the industrial sector with the technology that we have today. So Andrea, I'm going to turn it to you, if I may. Johnson Controls is one of Europe's major providers of large heat pump systems. And from what I hear, you've had particular success in the industrial sector. Can you talk us a little bit through your company's experience across different countries and even subsectors and how this might have been different?
Sure. So yes, I think what's interesting, I think in the last 10 years, and as you say, we have been seeing a significant growth in the use of heat pumps in the industry. And yes, district heating is one of the growth drivers, but also food and beverage, pharmaceuticals, data centers. And I would say there are two key trends that I think are very positive. One, and I know we said we want to talk about industry, but we are connecting industry to the cities. I think when we think about one of the key cases we are seeing is the use of that waste heat from a process in the industry, connecting through the heat pump system into district heating that is actually providing them to the houses, right? So, and actually also with the use of renewable energy sources. I think this combination is a key trend, and we have a couple of very good examples on that. I think we've been recently in one of the largest data center heat recovery. District heating, and you can see this same model, the use of the waste heat from the process, then providing heating for more than 7,000 houses. So obviously the impact is very clear. We mentioned before food. I think we have also very good examples in our company of the pet food, for instance. It's one of the cases we have. Obviously there is a lot of heat being used in this in the manufacturing of it. And we're using that waste heat into providing into district heating. We also see very good cases of simultaneous heating and cooling within a meat food actually manufacturing. So very good examples of how this is integrating. I think that's one key trend. And the other one that I think it's also been addressed today is the overall. You could say many of the large industrial companies like us are looking at the decarbonization targets and are looking at how we can support in this decarbonization roadmap. And obviously the manufacturing facilities, as you say, are critical to the business and are a big part of the energy consumption. So what we are seeing is that we are more and more looking at more holistically using digital technologies also in terms of helping. The heat pump has a core play in this solution. But we are definitely making that part of a overall system and using digital connection to the grid, optimization of performance. I think that's also a key trend that we see that is very positive and is going to also help drive adoption.
Fantastic. Thank you, Andrea. Now, Michael has mentioned the food and beverage sector as a sort of low-hanging fruit. You just brought up the food and beverage sector. So I'm sorry, Sander, but as an expert in the food and beverage sector, I'm going to have to pull you in. And I find your profile particularly interesting because you're specializing in components beyond the heat pump, right? So more specifically, dryers and coolers. So can you talk to us a little bit about your experience, especially from the side of having to integrate high-temperature heat pumps into the global process?
Yeah, what makes the drying really interesting is that we have the source and the sink in the same process. Mm-hmm. So where normally as a heat pump you're looking at a source and a sink, just like Andrea mentioned, in the dryer the source and the sink are the same thing. So we are recapturing the energy from the dryer and condensing the air coming out of the dryer, and thereby we can recover 60, 70, 80% of the energy in the dryer, boosted with the heat pump to a high temperature. Michael already mentioned 120, 130 is what we typically need in the feed and food industry, and then bring that air back into the dryer, and so we can completely decarbonize a dryer, take out the gas burners completely, and remain with only 20 or 30% of the original energy in the form of electricity, which obviously can be decarbonized relatively easily. So that makes the application also more easy for us, because we always have the same temperatures in and out, more or less, and therefore the refrigerant and the compressors and everything can be more or less standardized for all of our dryers. So that makes it very attractive to standardize them.
You've even persuaded me. Thank you, Sander. All right, so Stefano, Clivet is also a major provider of large heat pumps also in particular, and I know you've enjoyed particular success in the commercial sector, and we've talked a lot about how that market has developed, but you've been making a lot of progress in the development and innovation around large heat pumps as well. So if you look back 5 years and think about where we started from a technology perspective and where we've come, what are you most proud of in terms of our accomplishments?
Well, first of all, if you allow me, I would like also to thank and share my happiness and pride of being part of a community, the heat pump community, of course, but also the European community, which is a community which could take such a strong stand, a strong policy towards decarbonization. Why I'm going to this point? Because basically is where we all started as clivet. In our experience, heat pump technology is the most versatile and flexible technology for building environment, to create dedicated thermal, to approach dedicated thermal needs, and eventually use wasted energy to supply thermal needs. This is the principle in which clivet always worked and was founded actually to realize the dream of fully decarbonized homes, and developed in developing a heat pump system targeting waste energy recovery, both from water or from air. So particularly, we are very proud of the experience for the last 25 years in air renewal heat recovery systems. So that's what we did in the last 25 years, but to go to your question, since 5 years we joined one of the global leaders in heat pump and home appliance product, the Midea Group. And within this group, our focus has been to bring all these concepts and this technology to the mainstream market, to have a higher impact, to make the products more competitive, more efficient, more reliable, and of course to cope with the new regulations in terms of refrigerants and so on. So that's what we did in the last 5 years. We are very proud of bringing to our customer this principle in a wider scope with a more sustainable approach. A very long speech to say that heat pump technology is a big opportunity not only for the big companies, the big global corporations, but there has been no moment when I was in HP Forum when I didn't learn something new. Also today I learn of new innovation in the heat pump industry, and I believe this is not only a key technology in next generation EU, but is really a great opportunity also for our society.
Fantastic. So you've mentioned a lot of things that I like. First, around how we've evolved the way that we recover waste heat energy. So thank you for your part in contributing towards reducing thermal pollution. I hope everybody remembers that expression, but remember, Thomas created it. But you've also mentioned another key aspect, which is the improvements around the technology towards reliability, right? And we talked a lot, I heard a lot today, again, from a consumer perspective, we need to upskill our installers, we need to increase the confidence in the heat pump system, so to get the consumers, but this is even more valid for industrial customers, right? And I'm sure, Sander, you're nodding because you agree with me, which is a good sign. Reliability is even more key there because something breaking down results in loss of production, which results in a loss of money, right? And ultimately, these people are running businesses. Sander, you seem eager to jump in, so I'm going to give you the...
Well, it's interesting because we just had this previous presentation about hybrid solutions in the building sector. And in industry, what we found over the last few years is that the only way we can convince our customers to go electric with heat pumps is if we initially give them redundancy with gas. And not because of this temperature limit problem that we may have in the building sector, but because of the technical redundancy. The uptime of the plant cannot be compromised. So a customer will only buy our electric heat pump dryer if we start it up with gas, proving that the gas is available as a backup. Then we slide in the heat pump sections in the second stage on purpose later on, so that they know that if anything goes wrong, they just have to flip the switch and go back to where they were. Now, in practice, we believe it's not going to happen that often. Heat pumps are reliable enough. If we do our engineering right, it should be okay. But if we don't supply this redundancy option, they don't dare.
That's really interesting. It's and it's a little bit different, right, from the decision making or the concerns that a consumer would have. Michael, I hope you can still hear me, and I still see you. So I want to bring SINTEF, because SINTEF has been doing a lot of work to address one of the gaps, right, the myths, let's say, which is heat pumps cannot deliver high temperature, which is needed for many industrial processes out there. So I want you to help us walk through some of the work that SINTEF is doing. And so is this a real concern that we should have, that there's a limitation as to what heat pumps can do?
I think from a technical and engineering point, we can quite certainly say we can always engineer heat pumps to higher and higher temperatures. And that is certainly what we have been trying to do in the last years. I think when I started my first high temperature heat pump project, 80 degrees Celsius, that was 10 years ago, was already considered a very high temperature for a heat pump. I think that is now not really, that's now a more moderate temperature. But of course, these heat pumps don't work if you don't have any form of excess heat or something to cool at the same time simultaneously. So there will be a practical limit, I think, where heat pumps actually are applicable. Of course, develop a heat pump up to 300 degrees would, in my opinion, require excess heat source or something to cool in the area of 150 or at least 200 degrees Celsius. And we don't find these cases in very many industries. So I think from that practical point of view, where to integrate the heat pump, that it makes sense, we will end up that the heat pump might only reach 150 to 200 degrees in the next years and will contribute to these temperature levels. Yeah, that is, as I said, not because of lack of engineering talent or technical feasibility, but just in the integration principle. It comes back to that basically.
Michael, allow me to ask you a follow-up question on that, because another theme that has been coming up is around affordability. So it's great to know that technology exists and could address the technical gap, but where we are today, would it make business sense for process owners to actually make the conversion?
I think it really makes sense, especially in countries where the energy prices are in favor of that. And I think Norway is one of the examples where electricity has the same price as a kilowatt hour supplied by fossil fuels. And there, a heat pump is, of course, also always an energy efficiency measurement. And then it makes a lot of sense to switch immediately to a heat pump because you're saving money in every hour of the operation. And the payback times in Norway are quite often significantly lower than 5 years, maybe even 2 years or so. In other countries where we see that the energy prices are more in favor for basically fossil solutions, it needs a little bit more convincing to actually invest in a heat pump because the payback times are really long. On the other hand, the industry knows now in 5 to 10 years, there will be a certain requirement to be electrified. And if we then again benchmark the heat pump technology with an electric boiler, we will save money immediately, and it makes a lot of sense, also financially, also with respect to the return of investment and the total cost of ownership, to actually start using heat pumps and have basically, bringing back my point also to what Sander was saying, maybe a fossil fuel boiler as a redundancy system or an electric boiler, but it doesn't make sense to use these systems. You earn actually money by a heat pump.
Fantastic. Thank you, Michael. And I know that was an unexpected question, so well done. You addressed it very, very well.
Thanks.
All right. So I think we've covered enough about technology, and I at least feel it. So hopefully the audience sort of feels that from a technology perspective, it's there, right? And we can address the majority. So I'd love to switch the conversation a little bit to talk about what is needed to accelerate adoption in the industrial sector. So Sander, I'm going to turn it to you again. We've seen in the past that technology readiness is not the only adoption factor that matters, right? So what do you think are the main challenges that lie ahead for the industrial sector, and what would be your main call to action?
Well, if my call to action would go towards policymakers, then I would immediately come back to Michael's point about pricing of electricity versus fossil fuels. Countries like Norway have got this organized already so that it is very attractive to put heat pumps in there and electric cars. And it's no coincidence that they have such high adoption rates. But the same is true, for example, in some Asian countries. South Korea is quite interesting. We've sold one electric dryer there. Even China is relatively interesting. We've sold one electric dryer there. Funnily enough, within the European Union, we haven't sold one yet. And that has something to do with the fact that fossil fuels are relatively low cost and electricity is relatively expensive. So then this COP of, let's say, a factor 3 is almost completely eliminated because the price of electricity might be 3 times higher than the price of gas, and then you don't make any money. So in Norway, you make a lot of money, factor 3 more or less. In China and Korea, we're pretty close as well. So the direction should be, let's make sure that electricity is low cost and that fossil fuel gets more expensive by CO2 pricing.
All right. I think that's very clear, and we've had quite a few sessions where there's been a similar call to action, so hopefully they got the message across. So Andrea, I'm going to bring you in, and let's imagine a scenario where technology is there, the price is fair. Is that it? Is that the secret formula? Is it a happy ending, or what else might there be?
Well, those are two key factors for sure. But I think there is more than that. I think obviously, we have talked about probably most of what I would consider are the key additional things that we need there. I think we talked today a lot about the commitment from the member states, obviously Fit for 55 policies that are going in the right direction. So I think that those things will help. We talk about stimulus, right, supporting that, and I have to say that is also an opportunity from a positive economic impact. And I think we refer to innovation in Europe. I think it's an opportunity for Europe actually to be ahead, this is a trend that I do see us being ahead of other regions. I think now I would say there's 2 other topics that I think also add there. Definitely also the commitment from the business world needs to be there, and I think this is something we are seeing. Many of us are really signing up for net zero commitments ahead even of what the Paris Protocol or other are already aligning us to. And I think that's important. And I think one element that I think we also have talked about is the knowledge. As much as here, probably we all, and you already identified who we are here, I think we all obviously are knowledgeable on the heat pump, and I think it's, but still there is not sufficient knowledge out there, even in obviously also in industrial sector in terms of and that also has to do with getting the right knowledge on the installers, on the designer, and also making sure that we are providing, to the point raised, the right services around that, because the reliability is key, and for the reliability you need to build the trust and you need to provide the solution around. So I think those those elements and together with that more digital aspects, I think are going to help are going to be needed too.
So would you agree that an even tighter partnership will be needed between heat pump manufacturers and service providers and industrial owners in this case?
Definitely. I think the relation is getting far closer. I think when we go into a heat pump project, we know we're going to be working together for a number of years only to design the right solution, but then we're going to be tied up together for many years during the operation. So I think that's definitely needed.
And I think it poses a very interesting challenge to us, and myself included, as heat pump manufacturers, because when you develop that close relationship, you can't just be an expert on the water that comes out of your heat pump system and the water that goes in. You need to be able to have a higher level conversation with your customer. You even need to be able to talk ROI, right? And business case and what I find, we were talking about installers, right? Even our sales engineers, sometimes they're just not built with that capability to have this sort of business level discussion, right? So there's also some work that we need on our side in terms of education and understanding industrial needs in particular, so we can speak their language as well. So Stefano, you're coming from a very successful country when it comes to heat pumps. Everybody looks in Italy and says, wow, right? It's not even anymore a discussion. If you're using a gas boiler in Italy, you're a bad boy. So I think Italy, and we see this mostly in the commercial sector, right? But it is proof that it can be done at scale. So as you're hearing about some of these adoption barriers, what other innovations do you think need to happen in this space?
Well, for sure, I would fully underline the importance of energy cost. That is really a driving factor. So I don't repeat, but that is the most important probably in the business. As far as barriers and innovation, I would, looking from Italy, consider already an innovation to look further, to give stability to the measures in favor of renewables and heat pumps. So I think going back to Europe, Europe is already giving a very, very effective tool set, as we were saying this morning. So that is very good, but on a country level, not always that is being used. So in various countries, we should really give a longer-term framework, fully adopting the European directions. Some countries, while we are talking of ETS, some countries are still talking of full load efficiency. That is totally out of time, I believe. So the real barrier is to give confidence to all the people that the long-term solution is there. And I'm very optimistic, to be frank, because really Italy is now very, very active in residential heat pumps, but we always must remember that already the current framework created a big change in the commercial sector, because we are targeting a 60% penetration of heat pump technology in HVAC systems up to 600 kilowatts. So, and it's very, very common to have megawatts systems, fully electric, driving only heat pumps. So I think that's already a good sign for all the markets.
Excellent. Sander, I see you eager to jump in.
Yeah, I heard the word optimism and I thought, oh yes, of course. We forgot to mention that, but of course I'm very optimistic as well. And there was two specific reasons. One is that at least the food industry that we're mostly active in is really going for decarbonization, just like Andrea mentioned, at full speed. They really want to go. They're just trying to figure out which technology to use. And in this one, heat pumps really have a big advantage compared to alternatives. The efficiency is the big point. And since the cost is going to be important, this savings, this COP, the 3 factor or 4 or whatever it may be in industry, is going to make a very big difference for heat pumps. So I'm very optimistic that industry will find out that the way to decarbonize heat up to, let's say, 140, 150, 160 C will be heat pumps.
Fantastic. Appreciate your optimism. I think we need more of that in this world. So knowing that we have approximately 3 minutes left, I have my last, bomb question, but I want to make sure we leave space. Are there any questions from the audience or maybe coming in online? Don't be shy. Oh, I see a question there from Soledad. Oh, prepare. This is revenge for you, Sander, because you asked her a complicated question.
Thank you. Yeah, I'm sorry, but I think you know that. It's actually related to the previous session where also the topic came up that the knowledge level from their in-built environment end users has to come up. I hear it also from industry point of view. You're saying that knowledge level has to come up. For built environments, I hope you can still hear me. No.
Can you talk with your hands? So
I can talk. I shout, but I don't think that helps. I can come closer. But is it better now?
Yeah,
Yes.
perfect.
Okay, perfect. But in the built environment, I think the government has a great role to play in this knowledge transfer. But I think for the end customers in industry, this is different. How do you see this? Who would take up this role of giving the knowledge to end users?
I think we have a new participant.
I think we have a Spanish translation here ongoing. I love it when these technical bloopers happen to me. All right. Did you understand the question?
Yes.
So it's essentially about the knowledge transfer. Anybody volunteering to take it?
Sure. I mean, I think it's a very fair point. We don't have it's not an end user knowledge building, right? So I think I would say it's probably our responsibility as an industry. I mean, and this doesn't go just from the heat pump manufacturers, but I would say from the whole from the designers on how we are building on the building side, on the industry, to the servicing, to our own, as you said, sales people in the organization. I think it's a common, and I would say obviously this is a big task for Thomas and the European Heat Pump Association, is to really educate, right? I think it's not a small task. It can start obviously from those who are today learning in terms of the engineering side to those who are actually sitting on advising about the decarbonization journey. So I would think indeed, of course, that those can also be supported by the government. There are obviously a lot of activities that the governments can support, but they would need to try to partner with the industry on doing that.
Excellent, thank you. Now, just because I want to hear one more thing from Michael, super quickly, Michael,
Yes.
to end on an optimistic note. So since Thomas has told everybody that I'm a Disney fan, I'm going to use here the Sleeping Beauty parallel. You go to sleep tonight and you're going to wake up in 2030. How do you envision Europe and the heating industry?
Oh, I think in this setting, I definitely should say that every process that can be electrified by a heat pump is electrified by a heat pump. That would be, of course, the dream scenario for, I guess, everybody here. And I also would like that everybody knows about heat pumps, at least. That's maybe the more realistic point to take. I think it's a little lack of knowledge out in the industry what a heat pump is and what it actually can do. For us, it seems obvious, but we have a lot of discussions which start actually that we have to explain what a heat pump is and what it actually can do. And at least by 2030, I think we should have tightened that gap, that knowledge gap, and educated everybody in this direction.
Thank you, Michael. Thank you, Andrea, Sander, and Stefano as well for sharing your expertise. I hope you walk out of here with a little bit more confidence that heat pumps is not just a solution for residential and commercial, but it's ready for the taking for the industrial sector as well. So thank you, and Thomas, I'll hand it back to you as well.
Thank you very much. That's wonderful. I'm a big fan of The Mandalorian, so we have to defend the small child, right? Against the evil forces of the fossil empire. Thank you for this enlightening and I would say actually concluding session, because it closed the loop of saying heat pumps can be used everywhere and heat pumps are available for all solutions. I pick up what you said, Andrea. We really have to engage more in communication and information on the different levels. I think on the installer and educational level, it's also a lot of your job. So you really have to go into universities, provide maybe even specimens so that people can learn about the technology. But I know that you're doing that. Maybe you can do more. Thank you very much. And Dominique, continue to push innovation forward if it includes heat
Always.
pumps.
Healthy and efficient buildings.
Thank you
That's
very
the future.
much. Andrea, thank you very much.